G'day viewers, Alan here again. New project. It's a big old dividing head that I got at an auction a couple of years BC, before COVID. It's in excellent condition, but it's missing a couple of pieces. So this video is about making the bits that are missing. Let's get into it. Okay, so I've got the dividing head down from its storage on the upper platform. But she's a big girl and got a bit of a weight problem. At 47 kilos with none of the attachments like the chuck or the banjo for the change wheels. It's a pretty heavy bit of kit. I bought it at an auction quite a long time ago now, and most of the pieces are here, as you'll see, but there's a few critical ones missing. Main thing missing is it doesn't have the direct indexing disc for the front here, and it doesn't have a way of mounting a chuck, or at least a back plate. I've got to work out something there. But the other pieces are here, as I'll show you. But this is quite an impressive piece of kit, really. I'll turn it round. I like the way that the indexing wheels are contained in the body of the thing and not hanging out at a lower level. It makes it easier just to stick it on a table. I haven't seen that in another dividing head. So this piece here is for mounting a banjo and a set of change gears, and it's designed to fit onto a Victoria milling machine, which has a drive out at the end of the table, so you can through a change gear set, gear train, turn spirals. I'm not sure I'll ever get around to doing that, but anyway, so I've got the banjo and the mounts for that, and it also had a good assortment of change gears. Such as this one example, which are pretty solid bits of kit. I've got the tooth numbers of the gears I've got written down somewhere, so and put that up if it's of interest. Right, so keep continuing going round. As you can see, it's a Victoria branded item. I have no idea how old it is. It probably dates back to the 1950s, but it's a very solid beast and it's had very little use as far as I can see. So you can connect and disconnect the worm wheel. So I'll keep on going around. So with the worm wheel disconnected, all this lot just free wheels, it is actually quite stiff to turn, but I think that's because there's quite a lot of preload in the bearings, which probably isn't a bad thing. Now the direct indexing thing, I have this piece which fits in there. So you have to line that notch up to get that piece in. See where we're at. I think that's about the right place for it. Right, so we've got a spring-loaded index pin there which we can hold out the way or bring into play. So I need an index disc to go on there. Now I started making this a long time ago, so I got as far as making a ring to go on there. And the idea is that you have 60 notches on one side and 56 notches on the other, and that gives you a pretty good selection of direct index things. Right, I'll just pull this back out of the way for a minute. Right, so that'll go on there, and I've got 3 screws that locate in holes. There's one, to hold that in place. And obviously I've made it reversible. So where I stopped was I didn't have a tool for cutting the slots in the back of that. This picture will give you some idea of what we're shooting for. So you're looking obviously at the edge of the wheel. Anyway, work stopped when I got to the stage of having made this last time, because I couldn't make the tool for doing that. But since then I've got my AR5 tool and cutter grinder sorted. So now I'm ready to go back and try to make the tool for cutting those grooves. So that's sort of where we're at. I'll just turn this round again, just show you that when this is engaged, you can see how that's, so actually it's the other way around. This would be driving that, this would be driving from the output shaft on the end of the milling table and allowing you to rotate to make your spirals and so on. So all of that lot's present and correct, but as I say, I'm missing the direct indexing disc and a way of mounting a chuck. And yeah, the oops, this spindle here I think is a bit unusual. It's an NT40 mounting, and I haven't seen that on other dividing heads. Not that I've got a lot of experience, but mind you. So what I'm going to do to mount a chuck on this is, and I want to do it so that this index ring can stay in place, and there's just enough of this protruding to give me a shoulder. So I'll make a chuck mounting plate, back plate, that'll fit over this centre boss. I'll take these off, these drive dogs, and bolt it on through the face onto that pattern. So then I'll have a chuck back plate, and I'll get one of the chucks where you bolt it through from the front face, I think. Anyway, so that's where I'm up to. I've got to make the tool for cutting these grooves. So I've got two choices that I can come up with, and I've worked out that the slots have to be a 30-degree included angle. You see a previous video where I worked that out. So I've got two choices. I've got a multi-tooth cutter with a 30-degree included angle. But to use it, I would have to grind all the points off to have about a 1.6mm wide flat on the end of the tooth to create the right shape for this to go into without having to go too deep into the ring. So that's one possibility. Obviously a few things to grind. The other possibility I might play with is I knock to this, I suppose you'd call it a fly cutter, sort of an arbor up from a bit of scrap, and can put a 1/4 inch high-speed steel tool in there and grind the profile I want on the end of that and do it with a single tooth cutter. Couple of reasons why I might want to do it that way. I can keep the diameter of the cutter a lot smaller than that, and I was going to try to do it with the this ring installed on the dividing head, but there's this lump that sticks out through the middle, so I was going to see whether this would have let me get close enough, and also I thought it might be a bit less work, although I've already knocked this up. So I think I'll start by trying the single tooth approach, see how that goes. Okay, so I decided to sharpen the tool bit up using my D-bit grinder, because that's got a feature here which is I've already set up with an adapter to hold a 1/4 inch 1/4 inch high-speed steel tool blanks. So I can just poke that in there, and that'll be a much easier way of doing it. I've got good control of the angles and so on. Anyway, let's have a look at one sharpening action. And you can see this is a pretty crappy grinding wheel. It doesn't rotate around the centre, so it's got an obvious amount of run out on it. So obviously I need to replace it, but for the moment it's what I've got, and it is doing the job. The other thing you might notice in this picture is that the tool bit is actually upside down, and to grind the 2 degrees side clearance effectively for both sides, you have to turn the tool over and then obviously change the angle on the holder. So you're seeing it in the upside down position. Well, let's inspect that and see how we're doing. Well, we're certainly getting the side clearance. Time to measure that up and see how we're really getting on. So I was trying to find a way of showing the 2-degree side rake on this thing. It's a bit hard to do that, but if I swing this right around, perhaps you get the idea. So I've got that clamped into a right angle corner. Now the tool bit's actually upside down in this picture, and so the clearance shows up on the on top of the bit, and perhaps you can see the gap just there. It's quite small because it's only a 2-degree gap. Okay, so now I've got the side clearances looking pretty reasonable. It's time to have a go at the front clearance. So we'll just be bringing this backwards and forwards across here a few times till we get a little bit of front clearance. That was probably more than I wanted. I think I might have made it too wide on the front there. We'll have to have a proper look at that with the calipers and see how wide that front nose piece is now, and then take a slipstone to those corners and take them off. So I measured the width of that front nose, and best as I could tell with the calipers, it's pretty much exactly 2mm, and that should be fine. It's less than the nose of the peg, so that's really all I need. So this is the ground item. I'm not putting any top rake on. I don't think I need any top rake. I've got the 15 degrees each side to give the 30 degrees included, and then there's 10 degrees front rake and the 2 degrees side rake. So that should be good to go. All I've got to do now is take these corners off a little bit. How can I do that? Oh well, anyway. It'll be a very high stress point if I don't take those corners off. Right, so I guess I just got to chop it off now so it doesn't stick out the back as it rotates. So I'm going to do that with an angle grinder. Okay, so I've got the tool blank in the vise, and I've cut a notch to hopefully create a stress point. Right, let's see if we can break it off. There we go. Okay, so I've clean that up briefly with the bench grinder, and we've now got our piece ready to go. We don't need quite as much as that sticking out, but that'll do for a start. Now, I was quite keen to keep this long enough that all 3 screws would engage on it. I don't care to be hit by that flying out of the holder. Okay, well I guess we're all good to set up for a trial run on a bit of scrap and see how it works out. Actually, I'm wondering whether I've got enough relief on the back here. So it's probably alright. Maybe it wouldn't do any harm to take that corner off though. Okay, I think that'll do it. Gives all the extra clearance that it needs. Alright, just going to set it out. Let's try it out on a test piece. Well, I've just woken up to an unbelievably stupid design error. To use this cutter on this, I would have to be mounting this vertically in the thing and coming in like that. Yeah, great. The only problem with that is the outside diameter of the 40 collet is bigger than the cutter. So, no way can I, it's got to be all right. No way can I get it there anyway. So, that can't be used to do the job. And I'm going to have to go back to using the larger diameter cutter, which at least is bigger than that. So, I left this in because if nothing else, if you get a laugh out of my stupidity, well, it's been worth something. But I'm definitely claiming Bonehead Move of the Week award. Anyway, we move forwards. Let's come back and have another go getting this sorted. I'll have to sharpen this up to the required profile on the AR5. I will try and use this though, at least to test whether or not the groove that it created is right. It can have that purpose at least. Perhaps we'll start with 1000 RPM and see how that goes. I'm going to touch off first. Seems to go alright, so I might try a bit of automatic feed. No, it's 0.5 millimetre. Let's try a whole millimetre, see how that goes. We're going at a millimetre deep depth of cut here. It seems to be doing all right. Pretty slow process though. So I'm thinking I need to be about 3 millimetres deep. This might not start in it yet. Oh no, it does start. Try 1.5 millimetres. I'll be able to do it in 2 passes. I think this is asking a lot from the tool though. No, it seems to be coping. That's the 1.5 millimetre deep depth of cut. Let's have a look at that. And check out the tool in a minute too. Okay, well at least making this wasn't a complete waste of time because it allowed me to create a test piece for the profile that I was planning to do, and I think you can see here that that is pretty reasonable for what I'm trying to do. There's a 3 millimetre engagement there and it fits nicely in the slot. So I've got a template, if you like, to grind this to now, as you can see, because of the, well maybe you can't, because of the points I can't get in there. But at least now I know from this cutter, how wide it needs to be, how wide the cutting tips need to be at the business end. So I've got to get set up to sharpen this the same way, but I'm going to call that it for this video. It's getting a bit long and I don't know how much more time I'm going to get in the workshop just at the moment. So thanks for watching, and please join me when I resume with this sharpened and cutting the index wheel.